Today we are going to design the foundation, mat footing foundation for 23-story building. Previously we have designed the tall building. For that building we are going to design the mat footing foundation. This is the data obtained from the tall building design. We are going to design the mat footing for 22 meter square shape, 22 meter this side and this side 22 meter, and column spacing 6 meter, and we need to extend the 2 meter all round for designing mat footing. This is the data obtained from the tall building design. C1, C2, C3, C4, C5, C6, C7, C8, C9, C10, C11, C12, C13, C14, C15, C16, 16 columns having bearing, considering bearing capacity of the soil is 300 kN per meter square and allowable settlement 1 centimeter. And this is the column sizes: dead load, live load acting on the columns, having material M40 and HYSD 500. For C1 to C5 the column sizes are similar: 500 to 500, 500, 500, and for C6 600 cross 600 section, C7, C6, C7, C10, C11 are having similar cross section 600 cross 600, and for remaining sections 500 cross 500 sections are there with respect to dead load and live load for each column. Subgrid modulus is equal to soil bearing capacity by allowable settlement, which is given as 3 into 10 power 4 kN per meter cube. This is the design strip. Column strip width 0.25 L1 or L2, whichever is less. Here L1 and L2 is equal to 18 meters. This is the length 6 into 3, 18. Strip width 0.25 into 18 meter, which is equal to 4.5 meter. We start with by opening the software. This is the footing we are going to design, and we will run the analysis for this mat footing. First of all, open new file. Open new file. Here we are having design code IS 456 2000 and design preferences IR 456. Here minimum cover slabs we need to give as 50 centimeters, 50 mm, and preferred bar size is taken as 22. Okay. Next, here units we need to give for Indian standard metric. If it is not there, we need to choose the metric defaults. Next, we need to choose the grid only option. Here in this grid system, number of grid lines is taken as our column footing, mat footing is having 18 centimeters. We need to take the 19 grid lines, x direction and y direction 19, and grid spacing is equal to 1 meter. Click on OK. Here we got the grid lines with the grid spacing 1 meter, and next we need to define the material properties for mat footing and columns. Go to define menu, material, add the new material name M40, concrete, concrete cube compressive strength is equal to 40 Newton per meter square. Keep the remaining values as same. Click on OK. M40 material is created. Next we need to add the HYSD 500 bar. HYSD 500 rebar material. We need to give the modulus of elasticity values and the minimum yield stress 500 and the minimum tensile stress 5 standard values. Click on OK. Next we need to define the slab properties. Mat footing, M40. Slab thickness is given as 500 mm. Click on OK. Next we need to define the column properties, column sections. Here column, only two columns are there, 500 cross 500, material M40, 500 cross 500. Click on OK. Next we need to define another column property, column 600 cross 600, material M40, 600 600 mm. Click on OK. Click on OK. Next we need to define the soil subgrade properties. Soil 1, soil subgrade modulus is given as 3E 10 power 4. Click on OK. Next we need to define the load patterns for dead load and live load is given here, and for load cases dead load and live load linear static, and for load combinations we need to define for static and ultimate and for service load. Combination 1 dead load and live load 1.5, live load 1.5. For ultimate design and for combination 2 dead load live load 1. For service load normal, service load initial and service long term. Click on OK. Click on OK. We have defined the materials, slab properties, soil subgrade properties, and load pattern, load cases and load combination. Next we need to draw the mat footing. Go to draw menu, draw slab areas, draw slab/areas option, type slab property, mat footing. Next we need to extend this mat footing 2 meters on each side. go to select the mat footing. Here we need to make sure that for one area 4 edges selected. Next go to edit menu, edit areas, expand / shrink areas option. Here we need to give the offset value 2000 mm, 2 meters. Slab is extended all round 2 meter each. Next we need to draw the columns on this footing. Go to draw menu, draw columns. Property below is given as none. Property above is given as column 500. Height above is given 0. Height above is given 3 meters. Meter gap for each column. Column to column distance is 6 meters. Next we need to change the property for 600. Click escape when it is done. After drawing columns above the footing, next we need to give the loads acting on these columns. Next we need to draw the design strips for this along the center line of the column. Go to draw menu, draw design strips. For strip layer A, given as 4 meters. Click on right click when it is done. Next for strip layer B, designing the steps, we next give the point clouds on these columns. Click escape. Click on the column center. Make sure that one point is selected. Assign load data point clouds. Dead load and gravity load is given here. For column 1, gravity load is for dead load is 1850 and live load is 797.6. Size of load for punching shear is 500. We are going to give the dead load live load for similar sections of 500 cross 500, and for 600 cross 600 we will give the dead load live load. I have given the dead load for this column. Next we need to give the live load for this column. Click on the center point of the column. Make sure that one point is selected and go to assign menu, load data, point clouds. Here we need to give the live load. Live load is 797.6. For C2 3013.3. After giving dead load, live load for 500 cross 500 column sections, we need to give the dead load, live load for 600 cross 600 column section, that is C6, C7, C10, C11 for this four middle columns. C6, here we need to go to load data, point load, dead load, C6 column dead load 554 14.9, 54 14.9. Here we need to give the size of load for punching shear is 600 mm 600, x dimension 600 mm, y dimension 600 mm. Click on OK. After assigning the dead load and live load for all columns C1 to C16, next we need to add the soil property for the mat footing and material property for column section. Click on soil mat footing, right click, go to design option. Here design the slab as rebar material given as M40 HYSD 500. And soil property soil 1. After that, for column sections we need to give the material property for column. Right click on the column center and go to design, and we can see the load pattern, live load and dead load for this column. Assign the soil property for the mat footing. Go to assign menu, support data, soil properties, click on the soil one. Soil properties assign. After assigning all the parameters, next we need to run the analysis for this mat footing. Go to run, click on run analysis. We need to give the name if it is not saved. The analysis will go in here and we will get the displacement values at different points. After this, we need to go to run option and give run analysis and design. And we will get the displacement values. Each color shows different displacement values. And after this, we need to go to display menu, show punching shear design. Here we can see that all the some of the columns are not punching shear is not less than 1. Our motto is to make the punching shear less than 1. So unlock the model, go to define menu, material property, go to slab properties, click on the mat footing, and we will increase the thickness to 1000 mm. Click on OK, and again run the analysis. Again go to display menu, show punching shear design. Here still some of the columns are not, punching shear design is not less than 1 for this middle columns. Unlock the model, go to define menu, go to slab properties, mat footing, increase thickness to 1200 mm. Click on OK. Next again go to run and run the analysis and design. Yes, we got the punching shear design all or for all columns is less than 1. So our mat footing is now designed for which shows that our mat foot design is correct. Next we will interpret the results for this mat footing. We will run the detailing for this mat footing. We can see the shear forces and moment forces in display menu. For movement, here we can see the values along the strip length, and for movement also we can see. And for load combination and for load cases also we can see the different values along the strip length. Next we will run the detailing for this mat footing. Go to detailing menu. Go to run menu and give run detailing. Make sure that the checkboxes are given. Click on OK. The detailing has been completed. You can use the model explorer for detailing information. Go to drawing component views. Go to slab views. Here we can see the rebar cable. Having different lengths and number of rebars we are using, and individual slab views we can see. This is a rebar plan. And we can see the section view. This is the reinforcement design we are going to apply for this footing design. We can display the crack width for this mat footing. So we go to display menu, show crack width. We can see the cracks on slab bottom face and slab top face. You will see the cracks on slab bottom face. Different color shows the different crack width into 10 power 3 minus 3. These are the negligible cracks. These are at the bottom face of this slab, and if you want to see the top face, give the slab top face and apply. We can see that slab top face cracks. These all cracks are into 10 power minus 3. These are negligible cracks. This is how we will design the mat footing for 23 storage building. Thank you.